Let's begin Chapter 10, Section 2 on interest-bearing accounts and inflation. Starting with question 1. Becky received $12,500. She plans to invest the money for 60 days in an account earning 3.5% compounded daily. We're going to find two things: the compound amount, another way to say the maturity value, as well as the interest earned. Okay. Some things that are given to us is she's investing the entire $12,500, so that $12,500 becomes the principal, the amount invested. Okay. They also gave us 60 days, and this section we're going to be working on compounding daily, and it's a new chart. In section 1 we talked about compounding annually or monthly or quarterly, for example. In this case, we're going to have a chart for compounding daily. So just pay attention to the top of the chart and the title to make sure you're using the correct one. To find our maturity value, we're going to take the principal, the amount that's invested, and we're going to multiply that by the number in the table. We already said that the principal in this case is $12,500. Okay. To find the number in the table, it's the 3.5% interested compounding daily table, and we're going to look up 60 days. Notice that the days are on the left, and then the value from the table is on the right, and we are for sure using the 3.5% compounded daily table. Finding 60 days, remember the number on the left is the dates, and then the number on the right is the number in the table. I'm going to take that number back. So the number in the table is 1.005769730. Use all of those decimal places. Multiplying 12,500 times that number in the table, we end up with a maturity value of $12,572.12. That answers the first part of the question. The second part of the question is the interest earned. Now remember, the interest earned is the difference in the maturity value, the value at the end of the account, and the principal, the amount invested. So to find our interest, we're going to take the $12,572.12 and subtract away the $12,500 that was invested, and we get an interest of $72.12. Let's try that as a second question, number 2. Tom deposited $2,463 on January 10th, that same 3.5% interest compounded daily. Find the compound amount, that maturity value, and the interest through April 10th. In the first question, they gave us the exact number of days. In this question, we're going to have to calculate that. Now, we did calculate that before in a previous chapter, so it's just going to use that same method. How many days in January, how many in February, how many in March, and how many in April. In January, you want the end of the month, so from the 10th to the end. So we know that there are 31 days in January minus the 10 already used. There's 21 days left in January. In February, we're going to use all of them, and that's 28 days. In March, we're going to use all of them, and there are 31 days in March. You can use your knuckles to talk about the hills and the valleys. And in April, we're only going to use the first 10 days of April. Putting all of our days together, I get 90 days. And we're going to go through the same process. We're going to take, to find our maturity value, the principal, the amount invested, $2,463, times that number from the table. In this case, the number from the table, we're going to use the 90 days. So way over here on the 90 days, I have 1.008667067. So I'm going to take that back. 1.0086667 $2,481.067, and when we multiply, we get a maturity value of $2,484.35. To calculate the interest, we're going to compare the difference between the amount at the end of the account with the amount that was initially invested. So the $2,484.35, subtracting the $2,463 that was initially invested, and there's an interest of $21.35. Let's work on question 3. A money market account is opened with $8,500 deposited on April 15th. A second deposit is made of $1,500 on May 5th, and we want to find the total amount in the account, again that maturity value, on June 30th. Okay? And then later we'll find the interest earned. Now this one we're going to take in 2 phases. So the way your book introduces it is we're going to have invest $8,500 from April 15th to the end of the account, which is June 30th. So let's go ahead and calculate those days. Here's April, May, and June for the months that covers. And April, using my knuckles, I find out that there's 30 days in April, minus the 15 that are used already, and so there's 15 days left in April. In May, we're going to use all 31 days, and in June, we're going to use the first 30 days. And adding that up, I end up with 76 days. So to find the maturity value in this section, we're going to take the $8,500 deposited times the number from the table. And remember, the number from the table, we need 76 days. Let me grab that table and bring it over here so it's a little bit closer. For 76 days, I end up with the decimal 1.007313939. Taking that number to our calculation, okay, it was 1.007313939, and that gives us a maturity value of $8,562.17. Let's go ahead and calculate the interest in that time. Remember, you're taking the maturity value and subtracting away the amount that was invested. And that gives us an interest of $62.17. Hold on to that, because we have a second part of the account. Okay, I'm even going to switch colors here. In the second part of the account, we have money that was deposited on May 5th. Okay, so we have a deposit of $1,500, and that's in there from May 5th all the way to the end of the account on June 30th also. So similar to how we calculated a minute ago, we need to find out the number of days to be able to look in our chart. So we've got May and June for the months that are covered. On May, I found out that there are 31 days of May minus the 5 used, ends up with 26 days left. And then we're going to use the first 30 days of June for a total of 56 days. So for this maturity value, the amount invested was the $1,500 times the number in the table for 56 days. I'm going to scroll back up here. And for 56 days, I get this decimal, let me bring it back, 1.005384048. And multiplying, I get $1,508.08. To calculate the interest, we're going to compare that amount at the end of the account and subtract away the amount invested, and we end up with an interest of $8.08. To finish the question, I'm going to put together the amount that was invested on April 15th and the amount that was invested on May 15th and put their two maturity values together. Okay. Get a little more space here. So total maturity value. So we have the first one here of $8,562.17, plus we have the second one, $1,508.08, and so total, I get $10,070.25. And that's our total maturity value. For total interest, we're going to do the same idea and just take each interest together. So we've got our first interest of $62.70 plus our second interest of $8.08, and that gives us a total interest of $70.25. So you can take a question like this with multiple deposits and just make each deposit its own maturity value and its own interest, and in the end you can add them together.